Hi, so we are going to work on confidence interval review questions. Our first question says, suppose we have collected data from a sample. The sample mean is 7 and the margins of error is 2.5. And so we are supposed to find confidence interval. And in this case, we need to find the lower limit and the upper limit. So let's do our calculations on this side and sample mean, and also we are given standard error, or not standard error, margins of error. So sample mean is given as 7 and margins of error we are given 2.5. How do we find margins of error? We can find margins of error by taking z-score times standard error. So in this case, since we have a sample mean, we can find, if we have sample mean and margins of error, we can find lower limit, and also we can find upper limit. To find lower limit, just put equal sign, take 7 minus 2.5, and so that's our lower limit, and put equal sign, click on 7 plus 2.5, and so you can get upper limit. So everything was calculated for us here, so it's good. Now let's look at the second question, which says calculate the z-score for a confidence interval when confidence level is 95. So in this case, we know that our confidence level is 95%. And to find the z-score, we can use the following formula. It is confidence level plus 100% minus confidence level divided by 2. So this means we are taking 100% minus confidence level, which is the probability of the center when we consider normal distribution. And then we'll take probability at the center plus probability of the left tail. So we have 100% minus 95 divided by 2. So in this case, we're going to use this formula as follows. So just put equal sign. Before doing that, I'm going to write here 100%. So I'm going to write 100% so that I can use Excel function. And also I'm going to just type 2. Now for z-score, we can put equal sign, which is confidence level, that is 95, plus 100% into bracket first. 100%, I'm going to click 100%, and that is minus confidence level, which is 95 divided by 2. So if you enter, we have 97.5, and to get the z-score, we're going to use norms inverse, and we're going to click on this probability, close the bracket, and so we have our z-score as 1.96. And since we have z-score, now we need, here we are supposed to find the z-score, so that's all. Let's see the other question. So this question says standard deviation of the weight of elephants is known to be approximately 15 pounds. So let's write that information. Standard deviation. This one is given, so it's standard deviation of population. And it's given as 15 pounds. Another information, we wish to construct 95 confidence interval. So confidence level is 95%. And we want to construct the confidence interval for the mean of newborn elephant calves. So 50 newborn elephants were weighted. So sample size here is 50 newborn calves. So the sample mean, here we have sample mean. The sample mean is 244 pounds. So we're going to work on A. So A says construct a 95% confidence interval for the population mean weight of newborn elephants. So in this case, the very first thing we need to do is to find the z-value of the confidence interval. So z-score, and formula for z-score, if you can remember, or to find the z-score of the confidence interval, it is confidence level plus 100% minus confidence level divided by 2. So this one is the probability at the middle plus the left tail area, or probability of the left tail. So to find the to find that probability that will help us to find the z-score, we are going to click on, before we do that, let me put down 100% and so the 2, which we're going to use in our formula. So in this case, to find the z-score, just put equal sign, and confidence level is 95 plus into bracket 100% minus confidence level divided by 2, this 2 here. So we have 97.5, and so we can find z by using norms inverse. Click on 97.5 and enter. So we have 1.96. That is the z. And then we need to find standard error. And standard error will be standard deviation divided by the square root of n. So let's see if we have standard deviation. Standard deviation is given, sample size is given. So put equal sign, click on the standard deviation of population divided by the square root of sample size, which is 50, close the bracket, and so you can enter. Now we have this as standard error. In this case, we can find margins of error, and margins of error by formula, we have z-score times standard error. So we can put equal sign, click on the z-score, this one here, times standard error, this one, and if you can enter, we have margins of error. So to get lower limit, and also we can find upper limit. So our lower limit, we're going to put equal sign, and we need to take the point estimate, which is the sample mean, 244, minus margins of error, and the upper limit will be sample mean, which is our point estimate, plus margins of error, and so that will give us that particular value. You can bring them to 2 decimal points. So those are the lower limit and the upper limits. And in this case, we have constructed the confidence interval for that population mean weight. So it means the population mean weight will be between 239.84 to 248.16, in between these two values. So that's the interpretation of this confidence interval part 1. So let's see how we can work on the second question. I'm going to work here. It says a sample of 16 small bags. So here it is sample size, which is n. So the sample size is 16. I just identified that even before I read more. So a sample of 16 small bags of the same brand of candies was selected. Assume that the population distribution of bag weights is normal. The weight of each bag was then recorded. Average weight was 2 ounces. So sample mean is 2 ounces. Let's see if we have standard deviation of the population, and with a standard deviation of 0.12. So this can be the sample standard deviation. It is 0.12, and that also is ounces. Let's see another information. The population standard deviation of a population is 0.1 ounces. So we need to construct 90% confidence level. So confidence level in this case is 90, but also we need to use confidence level, which is 98. And remember, we have 100%. This should be 98%, and that also should be 90%. We need 2 in our calculation, but this is not the percentage, so I will change it from percentage to just number. So it is 2. So once we have this information, we can actually find z value. Z value or z score, and we're going to use the same formula. So I'm going to put equal sign, click on 90 minus, that should be plus 100%, this one, minus 90 divided by 2. So enter. So here we are considering 90%. And so z value will be calculated from 95%. Just put equal sign and type norms inverse, and we'll find the norms inverse of that probability, which will be now 1645. But also we can find the z value of 98%. And in this case, let me see if I can copy the formula. No, I cannot. So let's find the z value. Just put equal sign and click on the confidence level, which is 98, plus into bracket 100 minus 98 divided by 2. And so in this case we have 99.00, and we can find the value of this probability by using the function which is norms inverse. So click on the 99 and enter. So the value for 90 is 1.644 and for 98 is 2.33. So we can find margins of error. So let's find the standard error first. Let's find the standard error. Let me find it here. Standard error is standard deviation of the population, because we are going to use the value. We're going to use z value. So we are going to use standard deviation of population divided by the square root. So the square root will be of the sample size, which is 16. And close the bracket and enter. So remember, formula for standard error is standard deviation divided by the square root of the sample size. That's what we got. And the next thing is to find margins of error. Margins. So to get margins of error, we're going to find margins of error for this z value and for that z value. So let's find here, put equal sign. And in this case, we're going to take z times the standard error. Z times the standard error. So we get the margins of error when we consider 90%. And also, we can find margins of error by taking z times this standard error. And so in this case we have margins of error for both. Then we can find lower limit and the upper limit. So let's find lower limit for this first question here, where we consider 90%. It's easier to find the lower limit in this case because we're going to take sample mean minus margins of error and enter. To get the upper limit, we're going to take the sample mean plus margins of error and enter. So we have lower limit and upper limit for section A. Let's find lower limit for 98. So I'm going to put equal sign, click on the sample mean minus margins of error when we consider 98% and enter. Just put equal sign, click on the sample mean. In this, we are going to add margins of error, which is that value, and enter. So we have lower limits and upper limits for A and B. So you can see I just worked on those two questions together, and we have those answers. Now here it says, in a recent sample of 8 used car cells. So I want you to complete this question, but I'm going to give you this the sample size, which is n, and in this case it is 84. What are the information? Sample mean is given as 6,425, and so we need standard deviation. With standard deviation, so standard deviation. So this is given, so that's of population. And so that is 3,156. And assume the underlying distribution is approximately normal. And so we have confidence level, which is 95%. Now we're going to consider 100% and also 2, which will help in our calculation for this, for the z-value and so forth. So I want you to start from here to complete this question by yourself, which will make you ready for the final exam. Thank you.